A very good evening to everyone. Am I audible? Thank you, Dr. Paule. A warm welcome and very good evening to our resource person of today's session, Dr. Indranil Saha sir, all dignitaries, organizer of the program, and all dear participants presented in today's session. Today, there's a second session of this 2-month certificate program on data analysis using Excel and SPSS. And the schedule to be delivered by Dr. Shubham Pandey sir, but due to unavailability, the lecture is delivered by Dr. Indranil Saha sir. Today and tomorrow, the lectures delivered by Dr. Indranil Saha sir. Sir is currently delivering another session and will join shortly within 5 to 10 minutes with us. Meanwhile, I am introducing Dr. Indranil Saha sir. Now it is honor to introduce our distinguished resource person of today's session, Dr. Indranil Saha sir. Sir is currently hold the esteemed position of Scientist E at ICMR-Centre for Aging and Mental Health, Indian Council of Medical Research in Kolkata. With a career spanning 18 years, his contributions to the field of aging and mental health research are nothing short of remarkable. Dr. Indranil Saha sir's expertise encompasses a wide range of activities, including undergraduate and postgraduate teaching, training, and extensive research. He is a co-author of the renowned Essential of Biostatics and Research Methodology, now in its 4th edition, which has been an invaluable resource for researchers and students alike. His scholarly accomplishments extend to over 100 publications in both national and international journals, a testament to his profound impact on the field. Dr. Saha's research acumen is further evidenced by his impressive H index of 22 and I-10 index of 48, underscoring the significance of his work in the scientific community. Sir's primary areas of expertise lie in the epidemiology and biostatics, making him a leading authority in these critical fields. We are privileged to have Dr. Indranil Saha sir as our resource person today and tomorrow, and we look forward to a valuable and insightful session under his guidance. Sir is joined with us. Now, please join me in extending a warm welcome as we embark on this knowledge sharing journey.
Thank you, Mr. Amit Tiwari ji. Good evening to all of you. Am I audible?
Yes, sir. Audible, sir.
Okay, thank you. So sorry for late joining because of some other assignments. So should I start my session?
Yes, sir. It's on time, sir. Yes.
Okay, thank you. Is my screen visible to all of you?
Yes, sir. Visible.
Okay. So good evening once again to all of you, and good evening, Mr. Tiwari ji, for introducing me. And at the first, I'm grateful to Institute of Applied Statistics, Patil University School of Ayurveda, and the Ministry of Ayush for arranging this workshop for 2 days, 2 months certificate course on the statistical methods. So now today I will cover the most important one, and this is the first class of this session today. And this will be very important as this will cover the entire biostatistics in a very lucid way. And this is basically the backbone of the biostatistics class. So if you are comfortable and know all these terminologies, then it will be much easier for you to attend all the next consecutive sessions. So without much delay, I'm just going through my presentation. So what is research? So research is a quest for knowledge through diligent search or investigations or experimentations aimed at the discovery or interpretation of new knowledge. So all of you must be acquainted with the term research. You listen to from somebody that somebody is doing some research, or you himself or yourself, you are undertaking one research. So what does it mean? It means that you want to increase your knowledge. So how can it be done? It can be done by diligent searching or some investigations or some experimentations. So this is the WHO definition of research. What is the aim? Aim is to at the discovery or interpretation of new knowledge. Now, can anybody please tell me your research topic? Anyone? Anyone? Can anybody please tell me your research topic? Only research topic will do. I will not ask your objective. I will not ask your research question. Only the research topic. Anybody?
Yes, simply raise hand or write in the chat box.
Or you can say as well.
Yes, I will send.
Oja Kasu Etu factors Botanical survey. Very good. So we have got some of the responses. Clinical evaluation of Dhanvati in hypertension. Say for example the last one. Now my question is these things. What are the so naturally whenever you are undertaking some research, so certainly you should put certain questions, isn't it, to ask to answer your queries, isn't it? Am I correct? Am I correct? So what are the different questions have you put? So the thing is this, the different question that you have put or that you will ask, that you want to know from the research, this is known as the variable. So events that are measured in a research, these are known as the variables. Say for example, I'm doing one study on hypertension, that is the increased high blood pressure. Say for example, I have taken one question, what is your age? I've taken one thing, what is the gender? I've taken the religion. I've taken the weight. I've taken the height. I've taken the blood pressure. So these are the different things I will measure. So events that are measured in a research, these are known as a variable. Why these are named so? Because it varies from person to person, place to place, or object to object. So if I ask what is your age, you will see those who are present in this today's session, nobody's age matches with each other. Sometimes the age, the total age, the years may be same, but again if you think about the months or weeks, again it will be different. So age, gender, religion, weight, height, blood pressure. So these are known as the variable. Why these are known as the variable? Since it varies from person to person, place to place, or object to object. Say for example, I'm doing one study on blood pressure. So you see, this is the picture of a little boy, and this is the picture of a aged man. So I have measured his blood pressure. The blood pressure of this young boy is 116 by 74. And what is the blood pressure of this aged man? His blood pressure is 160 by 96 millimeter of mercury. You see his blood pressure is little bit low, 116 by 74. And you see in contrast, his blood pressure is much higher, 160 by 96. Can anybody tell me what might be the different factors because of which this difference exists? Can you tell me what are the different factors that might be responsible for this difference? Anyone? Very good. Manisha has written age. Very good. Because age is a factor that depends upon the blood pressure. with increase in age, there is increase in blood pressure. So somebody has written diet, somebody has written lifestyle. Nidhi has written lifestyle. Very good. Any other thing? Very good, very good. So what you have posted, you are absolutely correct. So Deepak Wali was written, that is the work, that is the physical activity. Either that person might be sedentary. Pooja has written ages, right? So these are the different factors. Smoking, Dr. Srikanth has written, Ashish has written stress, Ashwini has written physiological changes. Excellent, excellent. Thank you all, thank you. So you see, these are the different factors. Suchita has written stress. You see, what I have written, most of the things that you have already told me. So what are the different factors that are responsible for this difference? One of the factors, it might be age, somebody is weight, body mass index, dietary factors, lifestyle, stress, smoking habit, alcoholism. So what you have mentioned, so these are the different things that might be responsible for this difference. These factors, these factors, these factors are known as the independent variables. So please remember, these factors upon which blood pressure is dependent. These factors are known as the independent variables, and the blood pressure which is dependent upon so many things that you have already mentioned. So blood pressure is known as the dependent variable. So am I clear to all of you? So variable, it can be divided into two types. One is the independent variables and second one is the dependent variable. In this example, blood pressure is the dependent variable. And what are the factors you wrote in the chat box? And I have mentioned all of the things you have told much higher. All of you are absolutely correct. All those things, those who are manipulating the blood pressure, so these are known as the independent variables. So again, so this is one of the classification of the variable. Now I'm asking you one question. Do you think blood pressure will always be considered as dependent variable? Can anybody tell me? Do you think if I take blood pressure in one of my research, whether blood pressure will be always dependent variable, or it might be independent variable as well? This is my question to all of you. Anyone? You can answer. Then it will be, Abha has written no, Ashish has written yes, Anjali written not always dependable, Niranjan has written it may be independent in CKD. Excellent, Niranjan, very good. So you see the house is divided. Somebody is telling blood pressure will always be dependent variable, and somebody has written no, it might be independent variable as well. Well, one of your friend has written that yes, it may be independent. Shruti has written it might be both. So what is the correct answer? Correct answer is the both is the correct answer. We tag dependent and independent variable depending upon my research. In my example, what I told you earlier, I'm doing the blood pressure topic is my blood pressure, and I'm interested to see the different factors. So in my example, blood pressure was the dependent variable. Now some of you have said that in study of chronic kidney disease, or say for example in study of acute coronary myocardial infarction, that is the heart attack. No, I am interested to see the heart attack patients, how many of them were having high blood pressure. You see, in this example of myocardial infection or heart attack is a dependent variable. Or say, for example, one of your friend has written chronic kidney disease. Chronic kidney disease is the dependent variable. Then what might be the different factors that was responsible for chronic kidney disease or heart attack? There, hypertension is one of the factors. Diabetes is another factor. Smoking is another factor. Analgesic is another factor. Hypercholesterolemia will be another factor. So in this example, you see hypertension will be independent variable. So the take-home message is we cannot stamp one variable as dependent or independent. Rather, we have to think judiciously, cautiously, depending upon my research question, depending upon my objective, whether it is dependent variable or independent variable. I think it is clear to all of you. Now, variable can again be classified into two types. One of the variable is known as the simple variable, and another type of classification is the composite variable. What is simple variable? Simple variable means only one component is present. Say for example, you are telling age, you are telling weight, you are telling height. So these are all examples of simple variable. Now, if I tell you what is the full form of BMI, what is the full form of BMI? It is body mass index. How body mass index is calculated? It is calculated by, very good, very good. All of you have written very correctly. So body mass index, how it is calculated? It is calculated by dividing one variable by the other. Weight in kg, very good, divided by height in meter square. So what Joydeep Nayak has written very correctly. So weight in kg divided by, Chinmoyi has also written very correctly, weight in kg divided by height in meter square. So you see, BMI is one such variable, but two different variables are there. So BMI will be considered as composite variable. Am I clear? So BMI can be considered as composite variable because two different variables are included in the BMI. Very good. Next, so variables, you see, again we can ask the variables in different way. Where is your residence? We can ask. We can also think about, say for example, so many children, under 5 children, they are admitted in a hospital ward with a history of loose motion, diarrhea, and vomiting. And now we have assessed the dehydration status. Now we have categorized the children according to dehydration status. Some children, they are having no dehydration, some of them are having some dehydration, and some of them having severe dehydration. So you see dehydration status of your child. Again, again, one might be the variable is what is your weight. Weight is also one of the variable. And again, another variable might be what is the pulse rate. What I have written 4 different questions, because 4 different questions, they are typical examples of 4 different variables. Let us see. So variable, it might be qualitative variable or it might be quantitative variable. So what is qualitative variable? So that variable we cannot measure, but we can say like this thing. So qualitative variable, it can be nominal variable or it can be ordinal variable. What was my first question in the last slide? If you remember, what is your residence? The answer might be rural, the answer might be urban, or the answer might be the suburban areas. So the urban or rural, this is an example of nominal qualitative variable. Then what was my next question? My next question was, what was the dehydration status of the child? So dehydration status, in that way I have categorized no dehydration, some dehydration, and severe dehydration. So you see there is one definite categories or ranking is there. So this is known as the ordinal variable. So variable are qualitative. Qualitative, it might be of 2 types, nominal or ordinal. So nominal example is the urban, rural, or gender, male, female, like this thing. And ordinal, when there is some ordering is there, like no dehydration, some dehydration, something like this thing. So say for example, socioeconomic status, low socioeconomic status, middle socioeconomic status, high socioeconomic status. So these are examples of ordinal qualitative variable. Now what is quantitative variable? Quantitative variable, from the name it is implied that the quantitative variable, it can be measured. It can be measured. Then again, quantitative variable, it can be divided into 2 types. One is the continuous variable and second one is known as the discrete variable. What is an example of discrete variable? You see the question that I was asked, you see, what is your weight? Say for example, you are asking me, sir, what is your weight? I am telling my weight is 72 kgs. Exactly, is it 72 kg? So if you are carrying digital weighing machine, you might see that my weight is 72.345. But for the sake of convenience, I am telling that my weight is 72 kg. So you see, some variables are there where we can place it by some decimal. So this is known as the continuous variable. And what is discrete quantitative variable? You see here, in discrete quantitative variable, it has to be placed in a whole number. You cannot say as fraction. You can say my weight is 72.5. But if I ask you, what is your pulse rate now? What will you say? You will say either 70 or 72 or 62, or somebody is having tachycardia. You are telling, sir, 110. Will anybody say that's 110.5? No. So some quantitative variable or something like this thing that can be quantitatively measured, and discrete means it cannot be expressed in fraction, it cannot be expressed in decimals, it has to be expressed always in a whole number, like pulse rate. And some quantitative, continuous quantitative variable, just like weight, or some biochemical parameters, something like this thing. Right. So these are all overall classification of the variables. Now you see one of the variable like this thing. From the picture, it seems that the student is a very good student. And somebody that telling the student it is as a bright student. You see, the picture seems that it is a picture of a very good student or bright student. But if you tell me, sir, why are you telling like this thing? So it is my assumption. So I'm thinking from the appearance that you see he's carrying one book and he's carrying one bag in the backpack, and he seems to be sober, right? Neat and clean. So some variables that cannot be measured directly, but it can arise from some assumptions. So this variable is known as the latent variable. Say for example, like this thing. If you ask me, sir, what is your objective criteria of tagging the student as a bright student? I don't have any answer. So I'm telling it seems to be a very bright student. So this variable is known as the latent variable. Now you see this is a dice. Say for example, I'm throwing it. Can anybody predict which will what will be the outcome? It might be 6, it might be 1, it might be 4, it might be 5. So some variables are there. We cannot predict from beforehand. So we term them as random variable. Right. So please remember, these are some of the things that we have discussed under the term variables. So variables means it varies. Again, we have talked about different examples. We have talked about independent variable. We have talked about dependent variable. We have talked about qualitative variable. We have talked about quantitative variable. Qualitative variable, again, it is of two types. Qualitative variable, it is again of two types, and quantitative variables, again, it is of two types. Qualitative variable, that is, it might be nominal, it might be ordinal, where quantitative variable, it might be continuous or it might be discrete. Again, another classification of variable is the simple variable like weight, composite variable like body mass index. Another variable is the latent variable and was the random variable. I think it is clear to all of you. If you have any question from this variable, please raise your hand or ask me directly. I will answer, or else I will go to the next one. Or else we can take all your questions at the end of the session. So now you see this is the picture. But what does it indicate? You see at the end of the class teacher, she's asking the roll number, and one student, she's raising her hand, yes, present please, or like this thing. So what madam is doing? Madam is basically collecting the data. You see, in your class also, you might have noticed from our early days when we were at nursery 1, people used to ask our name initially, then used to ask our roll number. We used to say yes, please, present, please, like this thing. So what is it? Actually, teacher is collecting the data. Now, what is the utility of this data? You see, at the end of a session, class teacher, okay, one has written independent variable once more. I will come back at the end of the class. Please remind me at that time. So you see, the teacher is collecting the data. Now you see what the teacher is doing. At the end of the session, teacher is telling, yes, roll number 1, he or she was present on 80% of days, absent in 20% of days. Roll number 2, his attendance was only 30%. Roll number 3, attendance is 90%. Roll number 4, attendance is 40%, like this thing. So you see, so after data is collected, data is basically goes some this thing, some processing, isn't it? So that is why the second picture tells. Now the third picture is this thing. You see, now the school authority has decided that roll number 1 Say for example, his or her attendance was very poor, less than 50%. So school authority, they did not allow the student to sit in the examination. Whether roll number 2 and roll number 3, their attendance was good and they were giving the examinations. So last part you see, it is basically the intelligence part. You see all the three pictures, they are quite related and aligned with each other. So what is this? The first picture, basically teacher is collecting the data. What is data? Data are facts that are expressed in numerical terms. Data are facts that are expressed in numerical terms. Rule number 1, present, absent. Rule number 2, present, absent. We write P or A like this thing. So, or like this thing, right? So it has little meaning. It doesn't have any meaning unless it is processed or compiled, isn't it? Otherwise, what you will do? On a single day attendance, it does not mean anything. But if you compile the attendance over a period of time, say for 6 months or 1 year, then it has some meaning. So when data undergoes some processing or compilation, then it becomes the information. So please remember, when data undergo thorough statistical processing, it becomes an information. So initially is the data, and through statistical processing, it becomes information. And at the end of the session, school authority has decided that yes, roll number 1 is not having good attendance, so I will not allow him or her to sit in the examination. So third part is basically the intelligence part. It is for the decision makers or policy maker based on the transformation of information. Is it clear to all of you? So first we collect. Okay, Dr. Srikanth, please remember your question. Please remind me at the end of the class. We will discuss. Certainly, we will discuss. So please remember. So data, the first part, when data undergoes thorough statistical processing, it becomes the information. And information, when it is utilized by the decision maker or the policy makers, it becomes the intelligence. So by these 2 slides, I wanted to share you the data, information, and intelligence. Clear? Now we will come to the next part. How do we classify data? One way of classification data is same thing what I told you in terms of variable. One is the qualitative data, and second one is the quantitative data. What is qualitative data? Say for example, I am asking here in today's session, what is the distribution of the participants according to gender? Right. Say for example, today, suppose 100 participants are there. Out of 100 participants, say for example, Amit Tiwari ji has the record. Amit ji is telling, sir, out of today's class, 40% they are male and 60% of the female participants. So this is the gender. This is the qualitative data. Why I'm telling it as the qualitative data? Because the gender, these characteristics cannot be measured. Gender cannot be measured, but can be expressed in frequency. How many of them are male? How many of them are female? Same stands for the religion as well. Hindu, Muslim, Christian. We cannot measure the religion. Rather, we can enumerate how many of them are Hindu, how many of them are coming from the Islam religion, how many of them they are coming from the Christian religion. So gender, religion, birth, death, we cannot measure the characteristics, but we can express in frequency. This type of data is known as qualitative data. Since we cannot measure the characteristics, we can only enumerate the data. Qualitative data is also known as enumeration data. In contrast, what is the quantitative data? Quantitative data is such a data where characteristics can be measured. Unlike qualitative data, that was not possible in qualitative data. I'm talking about gender. You will say, sir, this much of male, this much of female. What is quantitative data? What is the distribution of weight in this class? If I tell you, say for example, we are also having the data of individual weight of all the participants. Now I'm telling weight I have measured. Now I'm telling in this class, 50% of the students, they are having weight less than 60 kg. 20% of the students, they are having weight 60 to 70 kgs. Another 20% students, they have the weight 80 to 90 kgs, and rest remaining 5%, they are having weight more than 90 kgs. So this is weight is one of the example of the quantitative data, because here both the characteristics can be measured as well as frequency can also be measured. So it is numerical. It is numerical. You see, I'm recording your weight as 72 kg. I'm recording your weight is 50 kg, 80 kgs, or 67 kgs, or 76 kg. So it is numerical. Previously, it was non-numerical, right? So please remember, so when both the characteristics and frequency can be measured, this data is known as the quantitative data. In the previous example, characteristics cannot be measured, frequency can be measured, but in case of quantitative variable, both the characteristics and the frequency both can be measured. So it is numerical data. Example is the weight, example is the height, example is the blood pressure, etc. So please remember this thing. So qualitative data and quantitative data. So since we can measure the data directly, so quantitative data is also known as measurement data. So I think it is clear to all of you. Qualitative data, also known as enumeration data, and quantitative data, also known as measurement data. Next, very important thing is this: we can transform the quantitative data into qualitative data, but not the reverse one. Say, for example, I have taken your weight. Now, right. So now, according to weight, then I have also taken the height as well. Right. And then I have calculated the body mass index, and then I'm telling it is underweight, normal weight, or overweight. So when we are collecting the quantitative data, we can jolly well transfer the data into a qualitative data. Say, for example, I'm taking the height of all of you. Then I have made one classification definition. If someone weight height is less than this one, I will stamp them as under dwarf or less height. This range is normal height, and this range is tall. So right. So height is a quantitative data, but when I have transformed it, it has become a qualitative data. Similarly, blood sugar. If I measure the blood sugar is a quantitative data. But according to blood sugar, if I distribute the participants as diabetic and non-diabetic, it essentially becomes the qualitative data. Am I clear to all of you? So in your research, it is preferable that you should always try to measure the quantitative data, so that you will have the quantitative data as well, and you can, according to your necessary, according to your need, you can also transfer it as a qualitative data. Like example, like this thing. Suppose you are interested to measure the anemia level. So after measuring, you do not measure the response as anemic and non-anemic. You measure the response as a hemoglobin percentage, 11.2, 12 gram percentage, or 10 gram percentage. You write it down. You write it as a quantitative data. And when required, you can transform it as anemic and non-anemic according to the operational definition. So this is an example where you can transform quantitative data into qualitative data. But please remember, vice versa cannot be done. You cannot transfer qualitative data into a quantitative data. So it is always preferable. You should try to collect it as a quantitative form. Next is the continuous and the discrete data. So what is continuous data? It is basically nothing like this thing. So Dr. Dinesh has asked, we will discuss later on. So what is continuous data and discrete data? Continuous data and discrete data, these are basically a branch of quantitative data where we can measure. Now, according to measurement, if we can put a decimal, you see, what is continuous data? Unlimited number of possible values exist. Weight maybe 61.231345, but is reported as 61 kg. So possibility of getting fractions. So this type of data, these are known as the continuous data. Other example are height, hemoglobin level, etc. And what is discrete data? Same thing what I told you earlier. Limited number of possible values. It is always expressed in whole number and not in fraction. Example, pulse rate. Number of students in a class. number of players in a cricket match or in a team. You see, it has to be always in a whole number. It cannot be expressed in fraction. So please remember, continuous data means unlimited number of possible values, and discrete data means limited number of possible values exists. Next example, so discrete data, it is also known as the discontinuous data. Since it cannot be expressed in fraction, since it is to be always expressed in a whole number. Next is the another type of classification is the primary data and the secondary data. How this classification is made? This classification is made according to the source of data. Say for example, I'm telling you, you see, all of us will go to the outpatient department tomorrow, and we will measure the weight, we will measure the height, we will ask some questions to the patient, and we'll also measure the blood pressure. So which type of data we will collect together? This is known as primary data, right? So when the data are collected afresh and for the first time, this is known as the primary data. Now, if I tell you, okay, see, all of us will not go to the outpatient department, will not go to the OPD, and will ask the question from the patient. No, actually, we maintain one register. Some of you are telling to me, sir, we maintain one register, and we have all data over the past 6 months or past 1 year. How many patients have come and each individual record. Then I can tell you, okay, then we will not waste much of our time. You bring your register, and from your register, we will do one analysis and we will do one research regarding the how many patients have come, how many of them were hypertensive, how many of them are having some lifestyle factors, how many of them are obese, overweight, like this thing. So that data will become the secondary data. So am I clear to all of you? So according to source, data are classified into two types, primary data and the secondary data. So the data which is collected are fresh and for the first time, that is original in character, this is known as primary data. And what is secondary data? The data which have already been collected by someone else and used by another are called the secondary data. So if you ask me, I'm telling you one proposition, we will do one research. Now you're asking me, sir, which data you want, primary data or secondary data? If I tell you, we will go to the field, we will go to the OPD, outpatient department, and we will collect the data from ourselves. So it will become the primary data. But if I tell you, you bring some of your register, which is having the data, hospital data, and from that data I will do the analysis, then it will become the secondary data. So census data, all of you know, census data, it is collected by house to house visits. This is basically the primary data. But if I am doing one analysis based upon the census data, then the census data has become a secondary data to me. If you ask me, sir, I have heard that you are doing some analysis. Which type of analysis you are doing? So I will say I'm doing one secondary data analysis. Clear? Now the next one is the group data and the ungrouped data. From the name, it is very clear. Group data means when the data are presented in group. Say for example, in today's class, suppose I am telling 10 participants are there whose weight is 50 kg. 12 participants are there whose weight is 55.5 kg. So this is how we present. But if I present singly, then it is the ungrouped data. So what is group data? Data are presented in groups. You see 55.5, 2 men, 59.4 kg, 3 men, like this thing. And what is ungrouped data? Presented individually rather than in group presentation. Why I'm telling it differently? Because there are some different statistical formula for group data analysis and for ungrouped data analysis. That is why I'm telling. But for our medical sense, it is not so much necessary. It is just necessary to know about regarding the theoretical background. Now the last classification is the hard data and the soft data. When we were young, we didn't see digital weighing machine. We were having the normal weighing machine. Now that in weighing machine, somebody is telling, yes, his weight is, you see, exactly 72.5. And somebody is telling, no, it is 72.3. It was not a digital weighing machine, isn't it? So that data, it is subjective. Somebody is thinking, yes, it is 72.5. And somebody is telling, no, sir, it is 72.3, not 72.5. But if If I'm having one digital weighing machine, then there will be no problem because there will be correct recording of the data. So please remember, according to variability, data can be classified into hard data and the soft data. What is hard data? The hard data is displayed on a continuous scale as a digital readout or computer printout. So whatever results that are generated from computer generated or automatic machine stabilizer like this thing, these records will hardly vary. That data is known as the hard data. But what is soft data? Soft data is very soft in the sense that it is subjected to variability. I'm telling like this thing, you might not agree with me and you are telling something else. So this is known as the soft data. So soft data means when there is subjective variation might be there. So nowadays we are more interested to the hard data because now most of the machines are digitalized and semi-auto analyzer machine or like this thing, biochemical parameters also, they will hardly vary because these are all computer generated data. So this is known as the hard data. So till now, I have covered the variables and its different types. Then I covered data, information, intelligence, and then I talked about the classification of data. What are the different classifications I told? I told qualitative data, quantitative data. Then quantitative data again divided into two. One is the discrete data, one is the continuous data. Then according to source, primary data, secondary data. Then according to presentation, group data, ungroup data. According to variability, hard data, soft data. Clear? Now, the last session of today's class is the different scales of measurements in biostatistics. You see, we use some scales in biostatistics, the very basic things you have to learn. So these are the four scales. One scale is the nominal scale. Second is known as the ordinal scale. Niranjan, I will come to your question at the end. Nominal is the nominal scale, ordinal scale. Another one is the interval scale, and last one is the ratio scale. So please remember, these are the different scales of measurement. I remember in the way as Neuer. Why I remember by this mnemonic? Because N comes first, nominal, then ordinal, then interval, then ratio. So why I have written like this thing? If you ask me, out of these four scale, which one is the lowest most scale? Answer is the nominal. And then when you are going up, the quality of scale improves. So nominal is the most below scale. Ordinal scale is slightly better than nominal. Interval scale is slightly better than ordinal. And ratio scale is the best scale and it is also having all the characteristics. Am I clear? So you have to remember in that way. If anybody asks you which scale occupies the highest most position, ratio scale occupies the highest most position. Which scale occupies the lowest most position? Nominal scale occupies the lowest most position. Am I clear? Now, this is a picture of Lionel Messi and Cristiano Ronaldo when they were in the earlier team. At that time, they were in Barcelona and Real Madrid. You see, Messi is wearing jersey number 10. Ronaldo is wearing jersey number 7. Can anybody tell me whether jersey number, is there any indication in the jersey number? 10 is better than 7. So can I say jersey number 10 will play better than jersey number 7? Can I tell like this thing? No. Then why this jersey number? Niranjan has said no. Very good. Neha has also said no. Rakesh has said no. Then why this jersey number was given? Why this jersey number was given? Just to distinguish the players in the field. Just for identification. In Real Madrid, very good. Neha has written to distinguish them. So in Real Madrid, they will know, yes, jersey number 7, it is by the Cristiano Ronaldo. Jersey number 5, it is somebody else. Jersey number 10, it is somebody else. So the take-home message is this thing. We have written, Rina has written very correctly. So this jersey number is basically needed for identification of the person. It does not carry any other meaning other than identification. One cannot say the player who is wearing jersey number 3 to 5 is much better than the player who is having the jersey number 1. So please remember, this is a classical example of nominal scale. So it is simply a system of assigning number to events in order to level them. So what you have very nicely, you have correctly said, sorry, just for distinguishing, just for identification, these numbers are given. These numbers doesn't have any other meaning other than this identification. So this is a convenient way of keeping track of people, objects, or events. Example, male, female, urban, rural, blood group A, B, AB, or O. Can anybody say the person having blood group A is much better compared to the blood group B? No. So why blood group AB, and O? This is only for identification. One cannot say this one is better, this one is not so good. We cannot say like this thing. So this is an example of a nominal scale, lowest most scale. Again, one thing you see, it does not have any ordering. One cannot say urban people are better than rural or rural people better than urban. One cannot say females are superior than male, male is superior than female. One cannot say blood group AB is better than O or O is better than B, like this thing. So it is simply a system of keeping the track of people, objects, and events just for identification only and only identification. Next, second example, you see, I have already told you earlier, this child under 5 children, this is having no dehydration. That patient was admitted in a diarrhea ward with a history of loose motion and vomiting. But after careful examination, it was found that the child was not suffering from any history of dehydration. So we have categorized the child as having no dehydration. This child, you see, this child is irritated little bit, and this child is having some dehydration. Now look this boy. This boy is having severe dehydration. You see, eyes are sunken like this thing. Now it is also similar in terms of nominal scale. Like this thing, we can distinguish the person. We can say no dehydration, some dehydration, severe dehydration. That we were telling in case of nominal scale as well. But in case of ordinal scale, one added advantage is there from the nominal scale. Here, the categories, it can be ranked. It can be ranked. One can say that no dehydration is better than some dehydration, and some dehydration is better than severe dehydration. Isn't it? So one ordering is there. So ordering starts from ordinal scale. So since ordering is there, this scale is known as the ordering scale. You see, in nominal scale, no ordering was there, only distinguish. Here, we can distinguish, we can demarcate. In addition, we can place them in a meaningful order. That is why this scale is known as the ordering scale. But what is the limitation of this scale? Limitation of the scale is this thing. Ordering we can do, but there is no meaningful interval in between the groups. What does it mean? It means that we cannot say that some dehydration minus no dehydration equals to severe dehydration minus some dehydration. Can we say like this thing? No. So this is a classical example. So please see, so this is a classical picture of ordinal scale. Among the three ordered scale, ordinal scale is the lowest most scale because ordering starts from here. In nominal scale, there is no ordering. In ordinal scale, ordering is there. Then interval scale and then ratio scale. In all the three scales, ordering is there. But if you ask me out of the ordered scale, which scale occupies the lowest most position? So ordinal scale is the lowest most position. Next, this scale places events in a meaningful order. I told you an example of diarrhea. Say, for example, you are interested to classify the patients according to acute respiratory infection. We classify as no pneumonia, pneumonia, severe pneumonia, and very severe disease. This is also a classical example of ordinal scale. You can place the patients in a meaningful order, but interval is not specified. We cannot say pneumonia minus no pneumonia equals to severe pneumonia minus pneumonia. This is ridiculous. We cannot say like this thing because interval is not specified. But no attempt is made about the size of the interval. We cannot say very severe disease minus severe pneumonia to pneumonia minus no pneumonia. So this is the basic limitation of the ordinal scale. In spite of having some meaningful order, it does not have any meaningful interval in between them. So the next scale is this thing. You see, this is the scale. This is known as the interval scale. You see, two thermometers are shown in the pictures. One thermometer is showing 20 degrees centigrade. One thermometer is showing 60 degrees Fahrenheit. So the centigrade scale or the Fahrenheit temperature scale is a classical example of the interval scale. Here, the interval is specified. If I tell you, I am having one object, the temperature of this object is 80 degrees centigrade. I am having another object, the temperature of that object is 70 degrees centigrade. So one is 80 degrees centigrade, another one is the 70 degrees centigrade. And your attention, I am also having two objects. One object is 40 degrees centigrade, one object is 30 degrees centigrade. Now we can say here, we can say in this case, thus 80 degrees centigrade minus 70 degrees centigrade equals to 40 degrees centigrade minus 30 degrees centigrade, because the difference is only 10 degrees centigrade, 10 degrees Celsius. That is there. That was not present in the ordinal scale. So this is the beauty of the interval scale. So since ordering is also there, we can certainly say 80 degrees centigrade is much hotter than 40 degrees centigrade or 70 degrees centigrade. But at the same time, we can say the interval in between them. So since interval is specified here, we term the scale as an interval scale. So what is interval scale? Data are placed in meaningful order and have meaningful intervals between them. 60 degrees centigrade, 70 degrees centigrade, like this thing. In Celsius scale, difference between 100 degree and 90 degrees centigrade is the same as the difference between 60 degree and 50 degree. We can say here that we could not make this type of comment in ordinal scale. But here, ordering is also there. In addition, we are having meaningful interval in between them. This is the beauty of the interval scale. But what is the problem of the interval scale? The problem is no absolute zero is there. This is little bit theoretical in the sense, no absolute zero. Then what is 0 degrees centigrade? So 0 is there. 0 is there. Then how can I say no absolute zero? Please remember, this 0 is known as the arbitrary zero. Why arbitrary zero? 100 degree. But the thing is this, 0 degrees centigrade does not indicate complete absence of heat. What does it mean, 0 degrees centigrade? It is the freezing point of the water. So 0 degrees centigrade does not mean any absence of heat. So since it does not indicate complete absence of heat, we cannot make comment that 100 degrees centigrade is twice as hot as 50 degrees centigrade. We cannot make such comment from the interval scale. Am I clear to all of you? So please remember, since absolute zero is not there, we are having an arbitrary zero. We cannot say 100 degree is twice as hot as 50 degree. We cannot say like this thing, because 0 degree centigrade does not indicate complete absence of heat. Rather, it is the freezing point of the water. Clear? And the last scale is the ratio scale. You see, this is a weighing machine, and we are taking weight of one particular individual. So what is ratio scale? Same properties as an interval scale, but it has an absolute zero. You see, whenever one patient has come after a road traffic injury in our emergency room, and we are not getting any pulse, so pulse is zero. We are unable to record any blood pressure, so blood pressure is also zero. So that means the patient has already died. He has been brought dead in the hospital. So zero is also possible. Here it is absolute zero. But in 0 degrees centigrade, This is not absolute zero, rather it is an arbitrary zero, because 0 degree centigrade does not mean absence of heat, rather it is a freezing point of the water. But here in the ratio scale, it has the absolute zero. Weight in grams, weight in pounds, time in seconds, blood pressure, pulse rate. These are all examples of ratio scale data. So since these are all ratio scale data, we can say, suppose I'm having pulse rate now 100 per beats, and somebody has having pulse rate 50 beats per minute. Now you can say my pulse rate is twice as fast compared to that person who is having pulse rate 50 beats per minute. We can say from the ratio scale, since we are having an absolute zero here, that we could not tell in the interval scale. Now temperature scale, Celsius, Fahrenheit, these are classical examples of interval scale. I forgot to tell you another example. This is an IQ also, intelligent quotient we measure. This is also in the interval scale. Why IQ is an interval scale? Because IQ, it does not have absolute zero. If I say I have seen one person, his IQ is zero. What does it mean? IQ zero means that person is having severe disability, might be cerebral palsy or autism. So that person needs immediate attention. So these are the examples of interval scale, and these are the example of ratio scale. That is the weight in kgs, time, blood pressure, pulse rate, all are ratio scale data. Only one temperature scale is there that belongs to the ratio scale. It is the Kelvin scale, where 0 Kelvin, it indicates absolute absence of heat. The 0 pulse indicate an absolute lack of pulse. Right? So am I clear? So 0 Kelvin is possible, because Kelvin, the concept is little bit different. 0 Kelvin means each and every molecule has stopped vibrating. They are not vibrating. So 0 Kelvin is possible. So this is the only temperature scale that belongs to the ratio scale. But the other two temperature scale, Celsius scale and Fahrenheit scale, they belong to the interval scale. So what I told you earlier, therefore it is correct to say that pulse rate of 120 is twice as fast as pulse rate of 60. Am I clear to all of you? So these are the example of the ratio scale. So please remember, I remember in that way the mnemonic NOIR, N-O-I-R. NOIR means N stands for nominal, O stands for ordinal, I stands for interval, and R stands for the ratio. Whenever I am moving nominal to ratio, the scale's characteristics are improving, and the best scale is the ratio scale. Out of these four scales, which scale does not have any ordering? Out of the four scales, which scale does not have any ordering? The answer is the nominal scale. Which of the scales have the ordering? All the last scales, ordinal, interval, and ratio scales, they have an ordering. And if I ask you another question, out of the ordered scale, which one occupies the lowest most position? Then the answer is the ordinal scale. उससे बेहतर है interval, and the best one is the ratio scale. Now coming to the all the scales at characteristics. So distinctiveness. By which scale we can distinguish one person from the another? Nominal scale, it is possible. It is also possible by ordinal scale. It is also possible by interval scale, and it is also possible by the ratio scale. Is it clear to all of you? Next, ordering. Do we have ordering in the nominal scale? I've already told no. So you see, ordering present in ordinal scale, present in interval scale, and present in ratio scale as well. So ratio scale is the highest order scale, and ordinal scale is the lowest mode order scale. Next is the meaningful interval. So nominal scale, so it does not arise. Ordinal scale, I also told you, meaningful interval is missing. Meaningful interval starts from the interval scale. That is why the scale named as interval scale, and it is also present in the ratio scale as well. Next, absolute zero. Nominal we don't have, ordinal we don't have, interval we don't have, and I told you only ratio scale, absolute zero is only and only present in the ratio scale. Now, for the qualitative data. Qualitative data, we can get it from the nominal scale. We can also get it from the ordinal scale. But we cannot get it from the interval scale, and we also cannot get it from the ratio scale. Just for this thing, I'm coming back again here. What is about quantitative data? We cannot get quantitative data from nominal. No. Similarly, we cannot get quantitative from ordinal. We can get quantitative from interval. We can get quantitative data from the ratio scale as well. Now, can anybody tell me whether this row, qualitative data, is this row is absolute correct or it needs some editing? Open question. I have written qualitative data. We cannot get qualitative data from interval and ratio scale. But if you think about my previous slide, I told you that quantitative data can be transformed into qualitative data. You remember? So since we can get quantitative data from interval scale and ratio scale, similarly we can transform this data as qualitative data as well. So it is wrong to say that we do not get qualitative data from interval and ratio scale. Rather, we get the quantitative data and we can transform it as a qualitative data. So remember, qualitative data can be generated from all the four scales: nominal, ordinal, interval, and ratio. Is this clear to all of you? So this is one of the tests that I will not discuss this today. Rather it will be covered. It will be covered in the next two months. So you just remember this slide. So automatically it will come one after another. I have told you four scales: nominal, NOIR, nominal, ordinal, interval, and ratio scale. Please remember, non-parametric tests can be performed from the nominal and ordinal scales, since we get qualitative data. And since we get quantitative data from interval and ratio scale, we can do parametric test from here. Again, in some situation, we can also do non-parametric test in interval and ratio scale based upon certain assumptions. You just remember up to this much. It will be covered later on. Today is the first class of the 2 months certificate course. So what I have covered in today's class, I have talked about what is research. Research is a quest for knowledge through diligent search or investigation or experimentation aimed at discovery or interpretation of the new knowledge. Then I talked about the research question. Then I talked about the variables. Then I talked about the independent variables, dependent variables, and other types of variables. Then we talked about the data, information, and intelligence and classification of data. Then we have covered the different scales of measurement with examples, but I did not touch Likert scale and application. Tomorrow I will discuss. So that's all for today's session. So that's all for me, from my side. So now I'll be happy if you have any questions. So I saw some of the question. So I will ask. So I will ask you, please, if you can please ask me your question. I'll be happy to answer your questions. Amit ji, over to you, sir.
Yes. I request to all participants, please raise your hand to ask query in the live session.
Raise your hand or
type query in the chat
right.
box. Dr. Richa, please unmute yourself.
Or you can unmute yourself and ask me your question.
Yes.
Actually, whatever you have written in chat box, no, it has disappeared. I cannot see now. So that is the okay. I'm just trying.
Dr. Richa, please unmute yourself.
Okay. I can now get through. So one Nira. One question that I have got, that sir, please explain independent variables once more. So it has asked, right? So independent variables, there are two types of variables. One is the independent variable and another one is the dependent variable. In your research, what you want to assess at the end, that is basically known as the dependent variable. And the different questions or variables that you have asked to answer your question. Say, for example, in my example, I told you about I want to know about the blood pressure or hypertension. So hypertension is a dependent variable. And what are the variables I have taken to answer my questions? These are age, gender, religion, lifestyle, dietary habits, overweight, BMI, etc. So these all will come under the independent variables. So in one sentence, what I can say, if you add on all the independent variables, age plus gender plus lifestyle plus weight plus this thing plus dash dash dash, equals to the outcome variable or the dependent variable. Am I clear to DB? You have not written your name, it is written as DB. DB, DB sir, is it clear to you?
Dr.
DB sir is
Niranjan
not telling.
is that Dr. Niranjan says that what is the difference between variable and data?
Okay, I'm coming. Next question asked by Dr. Shrikant. Lipid profile or any investigation, independent or dependent variable. You see, there again, the Shrikant has asked very good question. Lipid profile, is it an independent variable or dependent variable? You see, it depends upon your question. It depends upon your research. If you want to assess the lipid profile and what are the different factors that are responsible for the lipid profile will be the dependent variable. But if your research question is something like this thing, say for example heart attack or chronic kidney disease, their lipid profile will come as an independent variable. Say for example, I'm doing one research with the heart attack patients and asking all the heart attack patients, how many of you had hypertension, how many of you have diabetes, how many of you had high cholesterol, lipid profile like this thing. So all this will predict about the occurrence of heart attack. So in this example, lipid profile, diabetes, hypertension, all this will come as an independent variable and heart attack will come as a dependent variable. So whether it is dependent or independent, it cannot be stumped. It varies. It depends upon your research question. It is your research topic. I think it is clear to all of you now. Dr. Dinesh Patil has written, but we can transform qualitative data like pain in quantitative data by gradation. Very good. Dr. Dinesh has very correctly said. But you see, we cannot transform it. We will discuss this tomorrow. This is known as visual analog scale. This cannot be one type of transformation, but rather it is a proxy indicator. I'm telling how much pain you have. Somebody is telling, sir, mild pain, sir, moderate pain, sir, severe pain. Now I am categorizing all this pain in a visual analog scale. In 10 centimeter, 10 centimeter scale. So one is telling this one. So I'm telling 75 unit, 10 units pain, 90 unit pain. So it cannot be transformed. That is the proxy indicator. Nirajan has said, what is the difference between variable and data? Variable is basically when I'm talking about individual question. Say for example, age. Say for example, height, weight, blood pressure, gender, religion. These are all example of variable. And data means is basically the response of this one. So present. Rule number 1, he's telling, yes, sir, I'm present. So I'm writing present. Rule number 2, absent. Rule number 3, present. So data are facts that are expressed in a numerical terms. Have you understood? So this is basically the data. So collectively, when we collect one thing, variable is basically an individual question. Individual question or individual research question like this thing. And data are basically collective term, data are facts that are expressed in numerical term. Say for example, in the class, suppose I have completed my class and my boss is asking, Indranil, in your class, how many of students were present? I'm telling, sir, the data is 70% were present, 30% were absent. something like this thing. Richaus Nagar has written that, can you please explain the latent variable and random variable? Latent variable means you are getting an impression, but there is no objective criteria of measuring the variable. Have you understood? So it seems to be good student. It seems to be a very bright student. But if you ask me, sir, wow, how did you say like this thing? I'm telling you, yes, I have objectively, I have created some impression in my mind. Okay, he's carrying one book. That means he's a good student. Suppose it might not be to the some good student. They always do not carry some books or bags behind. So can I say them as a bad student? No. So this is right, this thing. So latent variable is something that cannot be measured or it is unable to measure. But certainly we can measure it by making some objective criteria. Then it will not be a latent one. Right. So this is a latent variable, and random variable means when you are not in a position to predict. When you are not in a position to predict. Say for example, in a cricket match, say for example, World Cup is going on. Can one body say, you see some team are making run 110 and somebody is making run close to 400. So the run scored by a team, it is also not a predictable one. This is also unpredictable one. So you can see it as a random variable, something like this thing. So Anjali has written that, can you please tell me a clinical example of latent variable? Latent variable, you see, you can say like this thing. Say for example, I'm sitting in an outpatient department and I'm looking upon several patients with fever and rash, and some by clinical impression I'm making some diagnosis. This is a case of measles. This is a case of rubella, like this thing. So something in came like this thing. Latent variable means it seems to be a measles, but I did not adhere some criteria. Say for example, you can say like this thing. But again, I'm telling you, our intention is not to make it latent. You make some latent variable by making it more clear definition. You adhere some clear definition so that it will be objectively one. So that if you measure the variable, the answer you will get, I will also get the same answer by using the same definition. Amit ji will also get the same answer by using the same definition. So this is our intention, to make it more objective. Why the similarity between types of qualitative data and first two scales of measurement? You see, the concept behind the things are same. Qualitative data is basically the data that cannot be actually measured, but can be expressed in numbers. How many of them are male? How many of them are female? And you see the same thing is there. And in the scale also, nominal scale means we will only distinguish. Right? You see the concept is more or less same. That is why I have taken this class in a single shot. So variables, and that will go to data, and then the data that we can place it in some scales, nominal, ordinal, or interval or ratio scale. One has written that secondary data and secondary research. Secondary research means we are doing the research with the secondary data. That is the thing. So we are collecting secondary data to do the secondary research. Please explain, sir, composite variable. Composite variable, I have told you, composite variable is nothing but whenever a variable is made up of more than two individual variables. Say, for example, body mass index, it is a variable of weight and height. So two different variables are taken to make one variable. That is why it's known as the composite variable. Other example I'm telling you, Glasgow Coma Scale. Other example I'm telling you, Apgar score. So these are the different examples of the composite variable. So I think I do not have any question in the chat box. So if you have any more question, then I'll be happy to answer, or else we can discuss this tomorrow. Over to Amit ji, sir. Amit sir, over to you. You are muted, sir. Sir, you are muted.
Yes, yes. Thank you very much, sir, for a very informative and detailed session. I hope all participants get answers to their queries. If there is any query remaining, then you can ask tomorrow in the session. Sir will deliver one more session tomorrow. And I will request to all participants that try to interact live by unmuting yourself. Just simply raise your hand so I can send you a mute request. So try this tomorrow. So it will make session more interactive and get query easily. You will interact directly. So this is the end of today's session. Dr.
Amit sir, one request. Can
Yes.
we little bit prepone tomorrow's session a little bit? But if everybody is available, I'm not sure.
Yes, yes. Please, sir. Tell me the timings.
So I'm asking all the participants, are you available little bit earlier? Say for example, if we start a little bit earlier, say for example 5:30 or like this thing, will it be feasible for all of you, or it will be difficult?
Yes, please respond in the chat box so I can reschedule the session for tomorrow.
Then we can start the session little bit earlier, say for example 5:30 p.m. That will be easier for me as well.
Yes, sir.
If all of you agree,
yes.
then only I can start, sir. Amit ji.
Yes, yes.
So
Majority,
all of
yes, sir. Majority of the participants agree and the saying okay, yes, yes. And if someone are not able to attend, then recorded session are provided for the later access. But the majority says that 5:30 is okay, okay. Yes, sir. Feasible. Yes. Majority sir agreed, and so I will schedule the session 5:30 for tomorrow. And if anyone missed the session, then I will share the recordings for the session as well as. Thank you very much, sir, for today's most detailed session. Dr. Mahesh Kumar Hari sir, the Dean of the DY Patil University, are with us. If sir need to say anything, then welcome, sir.
I will share my presentation with Amit sir, and Amit sir will give it to you, all of you.
Yes, yes, sir. I will share the all PDF notes and all details with the participants.
Tomorrow's class is from sharp 5:30 p.m. Right?
Yes, yes, right, sir.
Great.
Tomorrow we will start at 5:30 p.m. So if you found any difficulty, you can call us at 12 to 4 p.m. So I will sort out your queries regarding technical issues, and I will start the session at 5:30 p.m. sharp. So we'll join earlier at 10 minutes before to avoid any technical issues. So thank you very much, sir, again. And tomorrow we'll start at 5:30 p.m. sharp. Thank you very much for today's detailed session, and thank you. This is the end of today's session. Thank you very much.
Thank you.
For all participants.
Thank you. Okay. Thank you all. Good night. Good night to all of you. Bye.